Okay, so we're moving into module 5. And in this module, we're going to talk about parallel, perpendicular, and intersecting lines. Okay, so this is where we are, right here. And if you notice something interesting, intersecting lines has been added to the module. Okay, so let's get to it. So, how do we know when two lines are parallel to each other? How do we know when two lines are parallel to each other? If two lines are parallel to each other, okay, if they are parallel to each other, we can know by taking a look at their m's. The slope or the gradient of the first line will be equal to that of the second line. So if I have y1 is equal to 3x minus 10, and I have y2 is equal to 3x plus 100. I can tell you by looking at their m's. See, this is m. This is m for the first line. This is m for the second line. They're both 3. So m1 is equal to m2, hence these lines are parallel. In fact, I could go a step further and let you in on a little secret. If they are perpendicular, if the lines are perpendicular, then when you multiply m1 by m2, you're going to get minus 1. You're going to get minus 1. So let's take a look at an example. If y1 is equal to 4x plus 2, 4x plus 2, and y2 is equal to minus 1/4 x minus 17. What I'm going to do here again is I'm going to take a look at their m's. m1 is 4. m2 is minus 1/4. All right? So m1 is equal to 4. m2 is equal to minus 1/4. According to this right here, if I multiply these two together and I get minus 1, then these lines are perpendicular to each other. So let's try that. 4 multiplied by minus 1/4. And you know how to multiply fractions, right? 4 is basically 4 over 1. So these two cancel right here. 1, 1, and we're left with minus 1. So lo and behold, when I multiply m1 and m2, I got minus 1. These two lines are perpendicular to each other. These two lines are parallel to each other. Of course, this sounds real simple, real easy, right? Let's try to get this to work. But before we do that, let's take a look at one more premise that today's module is going to be based on. One more premise. And that is what happens if the lines intersect. If the lines intersect, right? So I'm going to have a line that goes that way, and I'm going to have a line that goes that way. It doesn't have to be at a 90-degree angle. Okay, they intersect. All right. So for all intents and purposes, this is what we have. Okay. The point where they intersect right here have something in common. So if this is y1 and this is y2, at this point right here, y1 is equal to y2. So we can take whatever the equation is for this line, equate it to the equation for this line, and we can actually figure out what point these two lines intersect. This is the basis for that. All right, this is the basis for that. So let's get started. This should be an exciting class. All right, so what if I have y1 being equal to 2x plus 3? And I'm asking you to find a parallel line. So this right here, to y1, which passes through the point 2 and -1. So these lines are parallel. What does that mean? That means they don't come into contact with each other ever. They're parallel, right? But I'm asking you to find the equation of a line that is parallel. So, you know, that's okay. We know where to start. We might not know what to do yet, but we know where to start. Where do we start, guys? We start right here. Y is equal to mx plus c, right? Don't keep your pen in your hands and your paper blank and stare in the ceiling. Start at a common place. We know where to start. Do I have m? See, this is when you start asking yourself the question. So I have m. But wait a minute. According to the principles here, I should have m because m is going to be the same as the other line because they're parallel. And when they're parallel, m1 is equal to m2. See that? We're making progress here, right? So y is equal to 2x plus c. Now this right here still isn't a complete equation of a line. I don't have c, but that's okay. That's okay because in a previous module, I was taught how to find the c. I was taught how to find c, right? So I know it passes through this point. So if I use this point to find c, right? Finding c. So I write what I have. I have y is equal to 2x plus c, and I'm going to use the point 2 and -1. What does that mean? That means that when y is 2, x is -1. So 2 -1 plus c. And now I have a single variable equation. That's all right. I can handle that. I've been taught to handle that. Let's boogie. So I have 2 times -1 is -2 plus c. And I'm going to transpose this -2, bring it over here. So I have 2 plus 2 is equal to c. Hence 4 is equal to c. C is equal to 4. And that's all that I was missing right here. See? So y is equal to 2x plus 4. That's it. Not so big and bad after all, is it? Of course, I could go a step further. I could ask you to sketch this, but that's okay. You just completed the previous module, which taught you how to sketch this stuff, right? Of course, you could find the x and y intercepts. That's fine. You could handle all of this now, all right? But let's try another one. Let's try another one. So again, we're looking for the equation of a line which passes through 3 and 14. It passes through that and is parallel. It is parallel to 4x minus 2. Okay, so this is where we are. So let's boogie. We know what to do. We start at the same place every time. Y is equal to mx plus c. All right, at least put that on your paper. Do I have m? Of course I have m because they're parallel. They're parallel, so they have the same m. So this is the new equation that I'm looking for. Y is equal to 4x plus c. But what is c? Well, I've got to go and find c. I know how to do that. Of course I do. Finding c. So I write where I'm at, which is y is equal to 4x plus c. And I know it's passing to a point 3 and 14. What does that mean? It means that when y is 14, x is 3. So wherever I see x, I'm going to put 3. And then I'm going to solve this. This is 4 times 3 is 12 plus c. And I'm going to transpose this 12. So it's going to become minus on this side. 14 minus 12 is equal to c. 14 minus 12 is 2. And c is equal to 2. That's all I was missing here. Y is equal to 4x plus 2. That's the equation of the parallel line which passes through 3, 14. All right? So let's do one more. This time you're going to pause the video, all right? And then you're going to give it a shot, all right? So I'm given an equation for a line. It says minus 3x minus 2. It says there is a parallel line which passes to the point 1, 3. And we want to find the equation of that line. We want to find the equation of that line. This is where you pause your video, okay? Now, welcome back. This is where you should have started. Y is equal to mx plus c. We know what m is. See, m is right here. This is parallel. So y is equal to minus 3x plus c. We also know how to find c. So let's go ahead and find c. Start with what we have. We have y is equal to minus 3x plus c, and we know it passed to the point 1, 3. What does that mean? Y is 3 when x is 1. This is minus 3 multiplied by 1 plus c, and this is 3 is equal to minus 3 plus c. We transpose the minus 3, so it becomes positive when we transpose it. So I'm going to have 3 plus 3 is equal to c, hence 6 is equal to c, and c is equal to 6. That's it. So y is equal to minus 3x plus 6. That's it. Nice and easy like a Sunday morning. Nice and easy like a Sunday morning. All right. So let's go a step further. All right. So I have an equation. The equation I have says y is equal to 2x plus 5. And I'm looking for equation of a line which is perpendicular to 2x plus 5, but passes through 10 and minus 9. Now this is perpendicular now. Perpendicular. So I know exactly where to start. Here's where I'm going to start. I'm going to start at y is equal to mx plus c. If they were parallel, I would know exactly what to do here. I would know exactly what to do here. What I would do is I would come and I would put a 2 here, right? Because I know that m's would be the same. Not the case here. This one is a little trickier, just a little bit. Let's focus on this for a second. We'll come right back to our starting point. So what I know is that m1 multiplied by m2 is equal to -1, right? So what if I want to make m2 the subject of the equation, right? Which means that's the only thing I want on this side. What I'm going to do is I'm going to divide both sides by m1. So if I divide over here by m1, if I divide this by m1, these cancel, and I'm left with just m2. But whatever I do on one side, I've got to do on the other side, right? So what I'm going to be left with is m2 is equal to -1 over m1. That's the trick. Your negative reciprocal. What do I mean by that? Let's put some numbers in there. If I have 4 and I want to multiply it by something, so that I end up with -1, I better multiply it by the negative reciprocal. What's the reciprocal? Well, this is 4 over 1, isn't it? 4 is 4 over 1, so the reciprocal would be 1/4. And the negative of that would be -1/4. Look what happens. I multiply them, I get -1. What if I had 2/5 here? Right? I want to multiply it by something so that I end up with -1. The trick is to take the reciprocal of this, which is going to be 5 over 2, and take the negative of that. When you multiply these, you get -1. So all we need to do is take the negative reciprocal. Mathematically, that is represented like this, right? Negative reciprocal. So let's try that and let's see what happens. Let's try that and let's see what happens, all right? So m is equal to 2. M is equal to 2. I need to multiply that by something, which is going to be m2. Right? This is m1. It's 2. And that's going to give me -1. And my trick says, take the reciprocal of 2. That's going to be 1/2. And take the negative of it. So the negative reciprocal. So my contention is that m2 is equal to -1/2. Let's try it out. 2 over 1, which is 2, multiplied by -1/2. This cancels, I have 1 times -1 over 1, hence is equal to, this works. So the negative reciprocal works. Haven't seen that, the trick, haven't seen that little trick. What does that mean? It means I could come back here now and I could say, okay, wise guy, m is not 2. No, this is perpendicular, not parallel, but it is going to be the negative reciprocal of 2, which is going to be -1/2 x plus c. Ooh, and now we got them exactly where we want them. We have them exactly where we want them now. You know why? Because all we have to do now is find c. We start with what we have. Y is equal to -1/2 x plus c. And we know it's passing through 10, -9. Okay? So what that means is that when y is -9, x is 10. And of course, what we're going to do is we're going to work this piece out first. So I'm just going to bring down this -9. -1/2 times 10 is -5 plus c. And I'm going to transpose the -5. So I'm going to have -9 plus 5 is equal to c. And -9 plus 5 is -4 is equal to c. Look at that. That's all I needed. So y then is equal to -1/2 x -4. That is the equation. Can you believe you just solved that? Isn't that amazing? Isn't that amazing that we're able to do that now? That's awesome. What's even more awesome is you can always go back and rewind this video or ask me questions. What's even more awesome than that is you should hit the thumbs up button, subscribe. What's even better than all of that is that you've got to share this with a friend. You've got to. There's got to be somebody out there that can find this so easy to learn, as opposed to the struggles that we've been having at school and so forth and so forth. But you know what? Maybe we haven't quite learned this yet. Maybe that was just one example. Maybe we need another example. So let's try another example. So I have a line. A line is given to me, okay, as -4x plus 1. I know that I need to find the equation of a line that is perpendicular to this and passes through the point 8, 4. Remember, we're dealing with perpendicular, all right? Perpendicular. And this should be a lot easier. You know why it should be a lot easier? Because I taught you a trick. First of all, we all know where to start. This is our starting spot. Once we know our starting spot, we start looking at what we can infer from the problem. Well, I can take the negative reciprocal of -4. How do I do that? -4. What is the reciprocal of -4? It is -1/4. But I don't want the reciprocal. I want the negative reciprocal, which means if it's negative, then this better become positive because that's the negative of the negative. So my new m is going to be 1/4. So y is equal to 1/4 x plus c. Simple trick. Just take the reciprocal and then find its negative. And that's going to give me the gradient for the perpendicular line. But I still don't know what c is. And there was a point in time before I started this course that would have been a headache. That would have been a problem. That would have gotten me all bent out of shape. Not now. Not now. Now I'm just going to come here, find what I have. 1/4 x plus c, find the point that it's passing through, 8, 4. And I know what that means. When y is 4, x is 8. So wherever I see x, I'll put 8 plus c. Now I'll just do some algebra here. 1/4 times 8 is 2. So I'm going to transpose this 2. So I'm going to have 4 minus 2 is equal to c, hence 2 is equal to c, hence c is equal to 2. And that is it, my friend. 1/4 x plus 2. This is the equation of the perpendicular line to this line, which passes through this point. Nice and easy like a Sunday morning. Now you ready to hit that thumbs up? Now you ready to shut a friend up? Let's try one more. Let's try one more. This time, I'm going to leave you at it, which means you're going to pause the video. All right? So you're going to have 1/5 x. I'm choosing problems that would normally scare you away. Fractions scare people away, but I don't want you to get scared. I want you to realize that you've got this under control. So I'm looking for a line that's perpendicular to this, and it passes to the point 1, minus 3. 1 and minus 3. So a line that's perpendicular to this passes to the point 1 and minus 3. So again, this is perpendicular, right? So where do I start? Where I always start. Y is equal to mx plus c. And of course, you have the video paused at this point, right? Now I'm going to find m for this new equation. And it's going to be the negative reciprocal. The reciprocal of 1/5 is 5/1, which is really just 5, right? So the reciprocal of this is 5. But I need the negative reciprocal. So I'm looking at -5. So y is equal to -5x plus c. That's all right. I got this. Now I need to find c. And I need to do this so I can let my teacher know and let myself know what I'm doing. So y is equal to -5x plus c. And it passes to this point 1 minus 3. What does that mean? It means that when y is -3, x is 1. So where I see y, I'll put -3. And where I see x, I'll put 1 plus c. So this is -3 is equal to -5. -5 times 1 is -5 plus c. And then I'll transpose the -5. So I'll have -3 minus 5 is equal to c, hence -8 is equal to c. That's all I needed. That's all I was waiting on. So y is equal to -5x minus 8. All right, that's it. That's it. So there's one more thing I want us to cover here. There's one more thing I want us to cover here, and it's what happens when two lines intersect. Okay, So I have two lines, right? I'm going to give you two equations. I'm going to give you two equations. One of them, y1, is equal to x plus 5. The other one, y2, is equal to 2x plus 3. And what's being asked of you is to find the point where these lines intersect, right? And that could be asked in many ways, right? I'll go with this one first, right? Find the point where y1 intersects y2. All right. So again, let's just view this for concept. So we have our axes, right? So you know this is y, you know this is x. And you have a line that goes like this. And you have another line that maybe goes like that. That's for argument's sake, right? So these are two lines, and you have a point somewhere on there where these lines intersect. Now, how do we know that lines intersect? Besides the fact that in this particular question, they tell us, we can know because if they don't have the same m, which is the same slope, which would mean they're parallel, at some point they're going to intersect. At some point, if they're parallel, they're going to be running parallel to each other. They will never meet. But if they have the slightest of angle with each other at some point, whether way down the line, whether it's not on this graph immediately, but somewhere down the line, they're going to meet. So they're always going to intersect if they're not parallel, okay? If they're not parallel. However, we don't have to go through the work with that in this case. In this case, they tell us. So this is just the concept of what's going on. And so what they're asking us to do is find the XY coordinates for this point. Ha! How are we going to do that? Seems a little tough, isn't it? Not so fast. Not so fast. All right, so that's the concept, right? So if I have that this one right here is y1, and I have that this is y2, okay? The point where y1 is equal to y2 is where this point is, all right? So where y1 is equal to y2 is where this point is. So that's what I need to find. Okay, so that's the concept of it, right? So let's try this again. So I have y1 is equal to x plus 5. All right, and I have y2 is equal to 2x plus 3. Now, watch this. What if I said, let them equal to each other? Y1 is equal to y2. Well, what does that mean? Okay. Well, x plus 5 at some point is equal to 2x plus 3. Yeah, because that's what it is, right? Y1 is x plus 5 and y2 is 2x plus 3, right? Now, this is still considered a single variable equation because it's still one variable, but that one variable exists in multiple places. Well, we can't have that. We're going to bring them together, right? So we could, from this step, we could do two things. We could say take the x over on that side, right? And take the constant over on that side, okay? Or we could decide that we want to take this over to the left and this over to the right. The idea is we want the variable that we're trying to solve on one side. Right now we have it on two sides and we want everything else on the other side, right? So let's just arbitrarily choose one for now, just for now, because this isn't the course that we're dealing with, right? What I'm going to do is I'm going to take this x on that side. And the reason I'm going to do that is because over here, the positive number is greater than this. This is 1x and this is 2x. So that's the reason, no other reason, right? So I'm going to transpose this x and take it on this side, right? Which means I'll have 2x minus x. And at the same time I do that, I'm going to take this 3 and take it over here. So I'm going to have 5 minus 3. Hence I have 2 is equal to 2x minus x, which is just x, right? Now, I didn't solve anything yet. I didn't solve it. I didn't find a point yet. But what I did find was the x coordinate of the point. Remember, I'm looking for a point xy, right? And I have found the x value so far. And what I could do now is I could substitute this x value into any of these equations and I should get the same answer, the same y value. Let's try it. So in y1, I have x plus 5. And so if I substitute the 2 in there for x, I get 2 plus 5. Hence, I get 7. So on this line, when x is 2, 7 is the point. What about on the other line? The other line says y2 is equal to 2x plus 3. When x is 2, I'll have 2 times 2 plus 3. Hence, I'll have y2 is equal to 4 plus 3. Hence, y2 is equal to 7. So again, when x is 2, y is 7. So basically, you see that the point 2, 7 is the point where these two intersect. When x is 2, y is 7. That's the point where these two intersect. This right here, even though these lines are not drawn to represent this and this point is the point we found for those two lines. Okay, that's the point we found, right? Let's try this one more time. Try this one more time. So I have y1 is equal to 3x plus 1. And I have y2 is x minus 7. All right. So again, what I have to do is equate them. So I got to say y1 is equal to y2. I'm looking for that point. So 3x plus 1 is equal to x minus 7. All right. So what I'm going to do is I'm going to take the x over this way now. All right. That's what I'm going to do. So then this x come over, it'll be negative. So I have 3x minus x is equal to minus 7 minus 1. This transposes, so it becomes minus, right? 3x minus x is just 2x. Again, this algebra right here is something that you can ask questions in the comments. Maybe I can make you a video to deal with that. We could see if I have a video already to deal with that. Maybe you could just peruse through the videos I have, or you could request one. I can see what I could do for you. Or find another way to contact me and I'll see how I can help you with that, all right? But 3x minus x is 2x. Minus 7 minus 1 is minus 8. Hence, 2x is equal to minus 8. Now I've got to divide both sides by 2 because I want just x, right? So x is equal to minus 8 divided by 2, which is minus 4. So I know the answer that I'm looking for is minus 4 and something. But what is that something? Well, I'm going to check it in both equations just to make sure. All right, 3x plus 1. Right? And so what I'm doing now is I'm saying when x is minus 4, what is y? Right? So this becomes minus 12 plus 1. So y is equal to minus 11. So according to this, this is minus 4 minus 11, right? Let's check the other one just to make sure, right? So y2 is x minus 7. So y2 is equal to minus 4. X is minus 4 minus 7. Hence y2 is also equal to minus 11. So you have minus 4 minus 11. Both of them gives that to you. And so clearly, this is our answer, minus 11. All right, so we're almost through with this course. You want to do some review. Again, the advantage of the video is you can go back in and review as many times as you like. But remember, down in the comment section, drop your comments. Also, keep this in mind, right? If there's a video and a topic that you want to see, let me know. I can see what I can do for you. All right. Next module, we'll be dealing with finding the length of the line, the midpoint of the line, and so forth, the line segment. Okay. And then we'll be preparing you for an assessment. All right. So that's what we have for today.